Welcome back, everyone. We are going to do activity 4.2b part 1 shortly, but before we do that, I want to review something that I think I may have neglected in activity 4.2a part 2. This is the tomato problem, and basically the gist of the tomato problem was that you were going to perform an experiment where you used 3 different amounts of fertilizer: 0, half of what's recommended, and fully what's recommended. And you are also going to water not at all or let nature do the watering versus additional watering. And what I'd like to talk about are these vocabulary words: factors, levels, and treatments. And what it comes down to is the following: is a factor is synonymous with an explanatory variable. So those two words are interchangeable. The levels are the amounts of each of the factors that you're going to apply in this experiment. So there are 3 levels of fertilizer: none, half of what's recommended, and 100% of what's recommended. But there's also another factor, and that factor is water, and there are 2 levels there: the just natural watering occurring from rain, and additional watering occurring from a sprinkler, for example. So if we put that all together, we have 2 factors: amount of water and amount of fertilizer. Fertilizer has 3 levels: 0, half, and full amount. Water has 2 levels: natural rainwater and additional water. And when we put everything together, we end up with 6 treatments. So those factors and levels and treatments are summarized in this table. Optigrow and water are the 2 factors. Optigrow's no dose, half dose, full dose are the 3 levels of Optigrow. Water, no water are the 2 levels of water. And the 6 combinations thereof make up the 6 treatments. So in this lesson, activity 4.2b part 1, we are going to talk about the placebo effect and how to avoid it in an experiment. We're also going to talk about the meaning and the purpose of blinding in an experiment. In the second half, we'll pick up on the remaining 2 bullet items. Another issue with experimental design that we have to deal with is called the placebo effect. And to deal with that, we often give some subjects in the experiment what is called a placebo. And to get into the discussion about that, I'd like you to pause the video and read part 1 right here before we come back together and talk about some of these questions. So before we get into the details of the placebo effect in this example and how to control that, let's do a little review. We want to know the population of interest, the sampling frame, and the sample. So I would say that the population of interest is all people with Parkinson's disease. The sampling frame, if you recall, is the list from the population from which we will be selecting our subjects. Now, ideally, that's the entire population, but very often it's not. In this case, it would be a list of all Parkinson's patients at this particular hospital, because they are going to be the ones that are asked if they want to participate in this experiment. And then the sample, in this case, is the 40 patients that actually took part in the experiment. In this next part, we're asked to identify any factors or explanatory variables, the level of each of those, and what the response variable is in this study. And then finally, we're asked to sketch a diagram for this experiment. So if you want to pause and try that for yourself, that would be great. Here are the answers that I came up with this particular situation. So the diagram looks something like this. I'm not necessarily answering this in the correct order. There were 40 subjects. They were randomly assigned into 2 groups. Group 1 we'll call the control group. Group 2 we'll call the treatment group. And the control group got no procedure whatsoever. the treatment group got the injection. In the end, we would compare the effectiveness of the two treatments, no treatment versus the actual treatment, and the response variable is the effectiveness of the treatment itself, the injection. This next question might be a question that I would give you as part of a question like this entire thing on a quiz or a test. How would you divide the 40 patients into the injection and the control group? Well, remember, the criteria is straightforward. It needs to be unambiguous, and somebody needs to be able to read your instructions, carry out the assignment, and essentially end up with the same results that you would end up. So my answer to this question would go something like this. Assign each subject a 2-digit number from 1 to 40. Read off 2-digit numbers from a random digit table, ignoring 00 and 41 through 99, along with any repeats. Assign the first 20 to the control group and the rest to the procedure group. All right, so far most of that was simply review. So let's move on to what we really want to get to in this video, and this is the idea of a placebo, the placebo effect, and something called blinding. So suppose the group who received the injection reported that they began to feel more positive and healthier on subsequent patient follow-up questionnaires. Would you be willing to conclude that this response could be attributed solely to the injection of the cells? Well, I don't know about you, but if I were a patient with Parkinson's disease and I got an injection that I thought was going to help me, just thinking that it's going to help me might actually help me. That is called the placebo effect. So essentially what I'm asking is it possible for subjects in this experiment to actually feel better or maybe even physically improve even though the treatment has zero effect whatsoever? And the answer to that is yes. It's called the placebo effect. For a very striking example of the placebo effect, I'd like you to pause the video and read this example about Mr. Wright. Before we go any further, I want to apologize for this morbid example, but it is a true example. You can actually research it on the internet, and it is one of the best examples of the placebo effect that I can think of. Back to our Parkinson's example. So to avoid the placebo effect, researchers decided to conduct another study where the control group was given a surgical procedure that was a simulated injection in their skull, but no procedure was actually conducted. So neither the control group or the treatment group knew whether or not they were actually getting the real treatment. This is what we call a blind experiment. A blind experiment is when either the subjects or the people administering the treatments in the experiment don't know which treatment the subjects are receiving. If neither of those two groups, the subjects or the people applying the treatments, know what treatments the subjects are getting, we call that a double-blind experiment. So a blind experiment could be either group, either subjects or the people performing the experiment don't know what treatments the subjects are getting. A double-blind experiment means neither group, neither the subjects nor the people performing the experiment know which treatments the subjects are receiving. So what are the benefits of the blind experiment? We'll call it a single blind experiment. The placebo effect could be at play here. So just by receiving an injection, people could improve their situation, just like Mr. Wright, even though the treatment has no effect whatsoever. So the idea here is that if we give everybody what is perceived to be an injection, then the placebo effect should affect both the experimental and the control group, the treatment and the control group, equally. And let's say that causes both of their conditions to improve somewhat. So what we've done is we've equalized the effect of the placebo on both of those groups. And now if the treatment actually works better than the placebo, you will see yet added improvement. And then we would be able to measure a difference in the effect due to the drug. And we've controlled for the placebo effect. Now, why might that not be adequate in this example? Well, if you had people that were doing the experiment knowing who received what treatment, they could also be biasing the subjects in the experiment. Not that they would be doing it intentionally, but maybe they get more attached to the group that's getting the real treatment because they think that they might survive, or they treat the two groups differently. That, in effect, could then have some effect on the improvement of the subjects. So that would be a reason why, in this case, it would be good to do a double-blind experiment. Don't let the people doing the experiment know what treatments the subjects are receiving. Don't let the subjects know which treatment they are receiving by giving them a placebo. So I would like to finish up this video with you working through this last problem one step at a time. So what I'd like you to do right now is I'd like you to pause the video, read problem number 2, answer part A. All right, hopefully your answer looks something like this. The factor, or the explanatory variable, is AZT. There are two levels. Either they got the AZT or they didn't get the AZT. The response variable is whether or not the babies had HIV. And the diagram would look something like this. The 324 HIV positive mothers, they were randomly assigned into one of two groups, either the placebo or the control group. Sorry, the placebo/control group or the AZT group. The treatments were applied for some period of time, and then a comparison was made between the number of babies that were born HIV positive for the two groups. All right, last part in the AZT experiment. I would like you to think about your answers to each of these. How does the study make use of the principle of control? How does the study make use of the principle of randomization? How does the study make use of the principle of replication? And how does the study incorporate blindness? All right. I would argue that the study makes use of the principle of control by randomly assigning the subjects to treatment groups. We're going to come back to that, though. How does the study make use of the principle of randomization? Well, the subjects were randomly assigned to the treatment or the control group, and as a result, we would hope any extraneous factors that are affecting these mothers would balance out between the two groups and therefore control the effects of them on the response variable, which is whether or not the babies end up being positive for HIV. We can't eliminate these effects, we just want to control them. How does the study make use of the principle of replication? Replication refers to experimental units. In this case, the experimental units, the smallest unit to which the treatments can be applied, are the individual mothers. So each treatment group had a significant number of mothers. 164 were in the AZT group and 160 were in the control group that received the placebo. So this experiment was performed on many experimental units, therefore we have replication. How does this study incorporate blindness? Blindness is incorporated here by the use of a placebo. The mothers did not know if they received AZT or a placebo. And I would argue that this also affects or is related to control. It controls the placebo effect. It does not eliminate the placebo effect. What it does is, if there is a placebo effect, it will occur in both the treatment group and the control group. If the mothers tend to get better because they feel like they're getting a treatment, both groups are getting a treatment. One group just doesn't know that the treatment is a placebo.